Okay, right. So today's session is actually quite different. We're going to learn how to use the Newton-Raphson method. It will come under what I think will be called numerical analysis, which is something we hardly do in high school, and to be honest, I haven't done it at almost all in university as well. And it comes to something quite shocking, something that I really never really knew that actually not all equation can be solved analytically. Okay, what does that mean? Let's say I have x squared minus 3 equals 0. You know how to solve it, right? We know how to solve it. We can pass the 3 to the other side, or we can, we can say it's x plus minus square root 3, right? What we've done here, we solve this equation analytically. But if you look at this equation, 1 over x equals sine x. Okay? In other words, we want to find sine x or 1 over minus x to find out for which x is that going to be the case. And if you can think about that, you can think about it a lot actually. You'll think about it a lot. You won't find a solution. There is no analytical solution. Analytical, I don't know what's the definition of analytical. It's like, I will use clever way of solving it. So how do you solve it? Well, it turns out there's many kind of methods. Today we're going to learn the Newton-Raphson method, and they're all what we call numerical. And they all work about smile and sign. Again, I don't know too much about it, but we use computers to solve it. So a computer will just kind of guess a solution and then try and do some kind of process to make a solution a little bit better, because we can try, we can say, we can just do it now. We can think about a solution. Let's say x equal 1. Let's put x equal 1. See if it works. If it doesn't work, let's try something a little bit better. Maybe a little bit half. See if that works. If it goes to the right direction, we know we need to guess. So it's guessing. This is what numerical analysis means, guessing. So to explain that, I need to show you something that I already told you I normally don't do, but for this time we will have to do it. And that is how to find the equation of a tangent to a curve, which you've done before. So let's say I have a curve, and I've got a tangent at a certain point. And I want to find the linear equation. It's going to be y equal mx plus c, or mn. What do you use? What letter do you use? Okay? So in other words, we need to find the m and the c. Okay? And this is some kind of curve. We'll call it f of x. How would I do that? We're doing this, we need to figure out some kind of formula here so we can use it later for our method. So how do we do that? What's the first step to find? I know what f is. I don't know what, let's say I give you a function. So what's the first step to do? We'll find the derivative. So I need to find the derivative. Let's say I'm looking at a specific point. We call it x1, y1. It could be 2, 5, or whatever it is. So I'm going to find the derivative of x, and then I will substitute x1. Okay? Now that's going to be my m, isn't it? That's going to be my m here. Will it be better if I give you numbers, like an example, or are you following me?
Yeah, we can give numbers afterwards.
Okay. So then I found the derivative. What's the next step? What is the next step? So let's do a number. Now we'll do something. So let's say f of x is x cubed. Okay? And I want to find out in the point 1, 1. This is this point. Okay? So the first step will be to find the derivative. And what is the derivative? It's 3x squared. That means that f in that specific point, when x equal 1, will be 3x squared. It's 3, it's just 3, right? Okay, so now I know m is 3. Okay, so now what should I do? I want to find that equation. So I know y equal 3x plus c. How would I find c? You substitute. Right, so I told you, we spoke about it at some point this year. What I tend to do is just put substitute, right? I'd say substitute 1 equals 3 times 1 plus c. That means c equal minus 2, and then we're done, okay? Minus 2. Okay? But now I want to give you, there's another thing you often see in the books. I don't tend to use it, but for now we will use it. There's another way of saying it. let's say, I know this 1, 1 is a point shared by the tangent and the curve. Now,
The equation is equal.
yeah, but now I forget about the curve and I say, okay, let's call this x and we'll call this y. What do I know about y minus 1 divided by x minus 1? Y minus 1 divided by x minus 1. What does that equal to in this specific example? The 3. It's equal to 3. That's the gradient, right? Because the gradient here is the same as the gradient here. It's a straight line. So that's just another way of getting this. Check out how it works, okay? So I just wrote that. Y could be any y on that line. So y minus 1 divided by x minus 1 equals 3. Then I will write it as y minus 1 equals 3x minus 3. Yeah? Plus the 1, y equals 3x minus 2. And we get the same thing. Can you see that? So now I want to formalize it. Okay? How do we write it in general? I'll do it here and then I'll erase it. So now I'm getting rid of this 1, 1 and this x cubed. Just trying to make up a general formula. I'm trying to do the general formula for the tangent of a curve. So my first step is to find first derivative of f at x1. Okay? I'm going to actually use the same f at x1. Okay? Now I'm going to say that that is going to equal to y minus something divided by x minus something. Okay? So that is y minus y1. X minus x1. That's it. That's how I can find out the formula. Because if I rearrange this, I'll write y minus y1 equal the first derivative, the derivative of the curve at the point I'm interested, time x minus x1. Okay, let me just see if this is what I'm actually looking for. Just pause here. Again. So I rewrote this equation in the same way, but instead of x1 and y1, I gave it slightly different notation, which will be more useful for me in a second. So I'll re-explain it. So let's say we have a curve f of x, and I've got a specific point. We'll call it, this is your x is a. If I want to find out the y, okay, in my other notation, this was x1 and y1. So if x is equal to a, some kind of number, then obviously the y will be simply f of a. So my mission, what I'm trying to find is the function of the tangent to a curve at x equal a. And what I've got to do first of all is find the derivative of f, substitute the value of x, what I called x1, now I call it a, okay? And then just use that formula. It's going to be y minus the y1, what I called now before, and now I'll call it f of a, equal f prime times x minus a. Okay? So that's the equation of the tangent to a curve of f of x at the point a, f of a. Are we happy with that? Okay. So now let's say I have some kind of function. We'll call it y equal f of x. And I want to know what's the y-intercept. I want to know what is the y-intercept, x-intercept is the solution for the equation, okay? The solution for the equation f of x equals, let me write it down over there. I want to find out the solution for that equation. In other words, what is x equal to? Like before, I gave you that, what was it? Sine x minus 1 over x equals 0. There's no analytical way of solving it. Okay? So what am I going to do? I'm going to guess. Okay? I'm going to guess. Okay? What I'm going to do now with my guessing, I'll develop a formula, then we'll do an example. So let's say I think that I'll start with a guess. I know kind of where it is. So we call the first guess is A1. That's going to be our first guess. Okay? So then what I'm going to do, I'm going to try and find out the tangent to that curve on that point. Okay? So you'll see why in a second. Okay? So, no, you'll see now why. Okay? You'll see now why. So That's why I explained to you how to find the equation of the tangent. We'll do that in a second, but let's say I found the tangent, the equation here. Now I'm going to find where that line, okay, where that line hits the the x-axis, in other words, the intercept. And I'm going to call that A2. What am I going to do with the A2 now? I'm going to substitute it in my original curve. Okay, I'm going to try and change things a little bit here, otherwise I didn't choose the right thing. Okay, so I'm going to substitute back again in my original curve. And then what am I going to do? I'm going to again find the tangent. See, I'm kind of bluffing here a little bit. I'm making things a little bit prettier. Okay, I'm going to find the tangent to the curve. It's A2. What am I going to find now? The intercept of this new function, and I'm going to call it A3. And then what am I going to do with A3? Substitute it again in the curve and find the tangent.
Can I just ask what's the point?
Because what's happening as I'm getting closer, this is going to be A4. What's happening every time? What am I getting close to? The intercept. So that is the solution that I'm trying to find. I'm trying to find the solution for the equation f of x is 0. Okay? So I start with a guess, find the derivative, find the equation of the tangent. That'll bring me to here. Again, repeat the process, find the tangent, find the intercept of the tangent. Every time I'm getting closer and closer and closer. Now, obviously, I need to have a good starting guess, isn't it? Because if I, let's say, started here, where is going to be the intercept? The intercept is going to be there. And I'm miles away. So I need to have a good guess. I need to have a good starting guess. And we will talk about how to do it and all that stuff later. But now what we're going to do is actually take an example. Oh no, before we do take an example, we need to develop a formula. Okay. So we're going to start by finding, okay, we want to, let me just clear up, make it a little bit less messy. So, okay, let's repeat. What am I actually doing? Okay, the process. It's, I guess, a 3-step process. The first process, to find out what they intercept, if I can't solve it analytically, is make a guess. It needs to be a clever guess. Okay? Then, I need to find the equation of the tangent at A1. Okay? Then I will find the intercept of the equation of the tangent. That's going to be A2. And then I just need to repeat the process. Find the equation of the tangent, this time at A2. And then find the intercept of the tangent. And that will give me A3. And so on and so on. It's called, this process is called iteration. Every time we get closer and closer. So let's do it. Now, I've just developed here how to find the equation of the tangent. Okay? So the equation of the tangent, I'll do that repeat here. Okay? What will be the equation of the tangent of f1? It's simply going to be y minus f of a1. Okay? I'm just using this kind of formula. Y minus f a1 equal the derivative at a1 x minus a1. Okay? So that's simple. How would I find the intercept? How do I find what? It's not just intercept, x-intercept. How do we find x-intercept?
Sorry,
When y is 0. Right? So how do I find a2? Well, a2, if I write, instead of x, I write a2. Okay? Then the y is 0. Okay? 0 minus f a1. Okay? In other words, if I want to find out what a2 is, it's just a little bit of algebraic massage. Okay, I'm going to add that to there. What is it going to be? a2 equal, what is it? So minus f a1, okay, divided by, so I have 2 minuses, am I not? No, I'm making a mistake. Let's do slowly. Okay, it's the end of the day, we're very tired. So we can open up. It's going to be minus f a1 equal f prime a1 times a2 minus f prime a1, a1. Okay? It's f prime a1 times a1. What am I interested in? A2. So I'm going to write it here. Because this is actually going to be important.
It's minus f.
A2 is going to be, correct me if I'm wrong, but I've got f prime a1 times a1. No, am I making a mistake?
Yeah, it's minus f a1 plus
Okay.
f a1.
Okay, I'll write it. I'm just writing this one first. So I've added that to that one. Okay, minus f a1. And now I need to divide everything by f derivative at a1. Okay, and then what I'm going to do now, where should I want to write it somewhere nice. Okay, get rid of that. Keep that one. I don't know why. It was quite important. And I'll write it down here in black. Just what I'll write is A2 equal, because that cancels. I'm developing into two terms. So I'm going to have A1 minus A1 minus f of A1 divided by the derivative of A1. You see that? I'm just going to pause, see that I got it right. Right? So this is really an important one because this is a formula to find the next A. So we start with a guess. Okay? We find to find what A2 is. I just did once. I'm never going to do that again. Never going to do it. All you're going to do is get that formula. Okay? In fact, I'm going to change that a little bit in a second. Because once I know A1, all I've got to find out what is f of A1, the derivative of A1, and just substitute A1, just substitute that, and I've got A2, which is a bit closer. Do I stop at A2? Is A2? No, I need to find A3. So, but it's, if I got A2, I get it from A1. To get A3, I just need to swap 2 with 3 and 1 with 2. And you see what? I'm just repeating the process now where A2 is like my A1 and A3 is the A2. And if I want to find out A4, what would that be? A3, and that all that is A3. Okay?
So it's basically just like trial and error.
It's trial and error, but there's a certain method behind it. Okay? And then we're going to move on to the final formula. Okay? That if I want we'll call it AN, or do they I think, yeah. Let's say AN, or AN plus 1. That's simply going to be AN, f of AN divided f prime of AN. It's always one ahead. Okay? And this is called, I think, the Newton-Raphson Formula method, and it is in your formula sheet. You don't need to memorize it, but you just need to kind of see where it's coming from so you'll be able to use it. So I'm going to pause here and let's do our first example. So Jitesh is asking, what is the AN? The AN could be, let's say, the 100th A. 100th A, which is really close now. So if I know the 100th A, I just need to do that, and I'll get the 101. Obviously, the higher the N, the closer I am to the real answer. I will never, and that's the thing with numerical analysis, I will never get the real answer. Or not always, sometimes I will, but a lot of the time I will never get it completely. But the more I do it, the closer I get to it. Okay? So let's do an example, then it will make more sense. Right, so our first example, it's pretty easy, and that's how we normally do that. So I've got some kind of quadratic equation, and this quadratic equation, the answers are going to be irrational. So, which means if it's irrational, you won't be able to factorize it. You're not going to be able to write down x and fine, that's not going to work. But you actually know how to solve it. How do you solve that kind of quadratic equation? What would you use? The formula. And let's just quickly do that, just for the fun of it. So it's going to be x12 equal plus 1, because it's minus b. 1 plus minus square root of b squared, 1 squared, minus 4ac. So minus 4 times minus 5 divided by 2, which is equal to 1 plus minus square root of, what is 1 square root of 21? So it's not a nice number, but you can find it. Okay? You can find it. Now what we're going to try and do is use this method. Obviously, it doesn't really make sense. You can solve it analytically, but it's often the case we do it like that. So we got to think about a number. And I guess the way of doing it is like you said you do, Olivia. You just start substituting, right? I mean, we're looking for an x. We're looking for an x that satisfies it. So a good one to start with is 1. Let's try 1. Look, 1 squared minus 1 is 0. It's minus 5.
How far off you are on that, will let you know where.
So we still negative. So let's try 2. 2 squared. 2 squared minus 2 minus 5 is 4 minus 2 is 2 minus 3. Okay, we're getting closer. So this is with 2. Let's try with 3. 3 squared minus 3 minus 5, 9 minus 3, 6. 6 minus 5 is 1. So we can see that's between 2 and 3. Yeah? So we know the solution between 2 and 3. What good guess would that be then?
I don't know, 2.5.
2.5, let's start with anything will do, but let's start with, I would start with, they chose 2.7, I don't know why. I would choose 2.5, maybe because maybe it's closer to 3, that's why they choose 2.7, but it doesn't matter, it will work anyway, Let's start with 2.5, so that's what I also thought. So we're going to use, let's just use that. So your first one, your A1 is 2.5, 2.5 let's say. We want to find out the second A, that's your first A1, so the guess. A2 will be 2.5 minus f of 2.5, 2.5, divided by the derivative of 2.5. Okay? So that means we need to find out two things. We need to find the value of 2.5 and the value of the derivative. So the value of 2.5, okay, let's write that down. Okay, that's 2.5 minus, what is the f of 2.5? I'll need you on the calculator there. Okay, so Olivia found out for us, just substituting 2.5 in here, okay, because that's your f of x, okay, is minus 1,25. Now we need to find the derivative. So we should probably write down the derivative, okay, that's easy, 2x minus 1, okay. So now we want to find the derivative at 2.5, so we need to substitute 2.5 here. Because that's the value of the derivative at x equal to 2.5. That actually we don't need the calculator because 2 times 2.5 is 5. 5 minus 1 is 4, right? So I'm going to put 4 here.
Okay.
I'll just pause here. So a little misconception here, okay? I started this lesson pretty much with finding a formula for a tangent to a curve. Then I use this formula for tangent curve for us to be able to find, to develop basically the formula. This is the formula. Okay? This is the formula, the Newton-Raphson Formula, that allows me to get closer and closer to the real solution or intercept in that solution for a function. But once I've got this formula, I do not need to find tangent to curves and all that. That was just once to show you. Now you just substitute. Easy, easy, easy. So we started with a guess. The guess was 2.5. Okay, we find the value of the function at 2.5. We find the value of the derivative at 2.5. We substitute in this formula. And what did we get, Olivia? A2 is? 2.81. And give me a couple more decimal places if you've got. Don't worry about it. No, it's fine. It's fine. Okay. Now, what do we need to do now? Find A3. So A3 is equal to, now we're going to do the same thing, but now AN is 2.81. So I won't need a calculator, don't worry, okay, because I'm going to show you something. So we're going to put 2.81 minus, now we're going to put the value of the function at 2.81, okay, and divided by the value of the derivative at 2.81. And that will give us A3. And then we can do A4. Now you might ask, that's a lot of work. But luckily, I'll show you how to do it with a calculator, which is really, really much easier. So, like I said, in theory, you've got to find A2, then A3, then do the same with A4, and then A5. And the question, first of all, when do I know to stop? And the other thing is, this is a lot of work. So luckily, the calculator, there's a certain function, the answer function. I don't know if you ever use the A and S, answer. I've never used it before. Okay, so there should be an A and S, Where do I have that?
Never use it.
Never use it. Can you see it?
Yeah, it's at the bottom where's the equal.
At the bottom, where?
The equal sign.
I don't, yeah, for me it's left to the equal, on a separate button, yeah? Yeah, okay, so just next to the equal sign. So what you're going to do is, you're going to write down, first of all, 2.5, which is what we started with. So press 2.5, and then write down equal, okay? Now, I'll tell you what to do, and then I'll explain. So then you press the A and S button, okay? And then minus, okay? Now, so far, okay, yeah, I'll do that, minus. Then open a fraction, okay? And write down A and S squared minus A and S minus 5. I'll explain in a second why we do it. And then divided by 2 times A and S minus 1. And just don't do anything yet, and I'll just explain what we've done here. Okay?
Price equals.
Okay, price equal. Yeah, what did you get? 2.81 something.
Yes.
Okay, so this just means, okay, that it's the same thing we just done now. Okay, so we put the 2.85. Everywhere we got an answer, it's sticking the last answer. So we wrote 2.5, so it's sticking the 2.5. Okay, but so far, why do we need the whole thing? I did it before. Because now, don't switch it off yet. Calculate, is it?
No, it's there.
It's there. Press equal again.
Oh, here's the next one, yeah.
What do you get now? Hang on, so the first one, and give me more decimal places. So what, the two?
2.81, how do I go back?
And there was, yeah, no, you
2.8125.
okay, then the next one?
2.7913.
And then the next one? Just read.
7912.
7912, and let's do more.
It keeps giving me the same one.
Give you the same one. Okay, so now I've answered both questions really. Okay,
Oh,
first of all, that's it. So every time you press equal, it repeats the same process with the last answer. It iterates. And when at some point when you see you're getting the same answer, then you don't need to carry on anymore, isn't it? You got the right answer. It's cool, isn't it? It's iteration. Now, obviously, you're not going to get the same answer. You're missing some, but as far as we're concerned, 4 decimal places, we're there.
Okay.
Clever, isn't it?
Genius.
Awesome. Okay, let's pause here for a second. Okay, just before we go over to the next example, just to say that what I typed in the formula, I didn't explain that. That's just for this specific example. I don't know if I didn't say it, but maybe you didn't notice that. What is A and S? Answer square minus answer minus 5. It's exactly that. That's the value of the function. X squared minus x minus 5. And what is 2 times answer minus 1? That's the derivative. So obviously every question, you will have something different. That's why I want to do one more example. Cool. So I think to finish up this lesson, we'll do one more example, which actually was the original question I've asked. How can I solve something like that? Sine x equal 1 over x. Which value of x will satisfy that? There is no analytical solution. Okay? So at this point, it's sometimes good to draw. Okay? So the sine x, this is obviously sine x. This is the curve sine x. It starts going up and then down. Okay? It goes from 0. We're working in radian. I'm trying to kind of get you to use radian. So it goes from 0. When does it come back to 0? 2 pi. And 360 is 2 pi. That means that's pi. What is that, by the way? Half a pi. Okay, 90 degrees. Okay. Now, 1 over x, what does 1 over x look like? What is 1? No, but what is it? It's an asymptote. Okay? Remember? It's a what, sorry? It's not an exponential. It's an asymptote. Okay, so exponential is, will be something like that, but it's not going to blow up to infinity. We'll get to it. That's a good question. So exponent, let's say e to the power of x, or 3 to the power of x. Yeah. It will get to infinity, but what does x have to be to get you to infinity? X has to be infinity. 3 to the power of a million is still not infinity. 3 to the power of 10 billion is still not infinity. But y equal 1 over x, that does blow up to infinity when x is equal to 0. Do you understand? This important difference, for asymptote. Okay, there's no asymptote on the exponent. Okay, so the first thing to do is probably draw it. And then, what does that mean? What does that mean? what does that mean? What is the geometrical, what x's am I looking for? For which x these two are equal, I'm looking for those 2 points, right? These are the two x where this equation is satisfied. So let's say in this case, I just want to find this x. I'm not going to bother about that one. I can do the same thing for this one, but I'm going to just find that one. There's no analytical solution. So what is the first step I have to do? Guess. Okay. What is a good guess?
Or less than pi over 2.
Exactly. So remember, to be able to guess, either way, by the way, they sometimes will actually tell you what to start with. So when it's very difficult to guess, they might tell you start with this, and then you just substitute an equation. Dead easy. But here, by drawing it, you can see it's somewhere between 0 and half a pi. So we can say that A1, what are we going to go with, Olivia? Okay, what's the middle between 0 and half pi? A quarter pi. Okay? So now, let's just get warm up, okay? Let's find out A2, okay? What do? We use the formula. A2 is A1 minus f of A1 divided by f prime of A1. Okay, I don't know why I'm writing it now. I just need to put pi quarter, okay? And now instead of A1, I'm going to put, I want to put f of a quarter, okay? But I don't want to just write f of a quarter pi, so f of a quarter. I want to actually substitute in the formula, okay? Okay, yeah, exactly, which one? So actually I missed a step here, okay? Because I'm looking really, I've shifted it to this one. It's sine x minus 1 over x. I'm trying to find out for which x is the intercept. So I need to find out the value of this function. So I'm going to write sine a quarter minus 1 over a quarter pi. So sine quarter pi minus 1 over quarter pi. Okay? So that is my function. Okay? And I'm looking for the y-intercept. Okay? Now here I need the derivative. So I need to find the derivative. Let's write the derivative. Okay? If f of x is sine x minus 1 over x, that means the derivative will be what? Sine, you remember what's the derivative of sine? Good. Cos x, and this one?
Well, it's minus x plus minus 1, so it's minus x minus 2.
Okay? And because I've got a minus here, but I've got a minus 1 there, it's actually plus. Okay? Maybe let me write it down like this. Sine x minus x to the power minus 1. Yeah, we normally do turn it into...
Yeah, okay.
Okay, and now you can see, the minus goes there, so it's x minus 2, but this is plus. Okay? Great. So now I've got to write down here the derivative, cosine and 1 over x squared, but at a specific x, it's pi quarter. So pi quarter. Okay? So I'll just repeat what I've done here. Okay? I found the function that I'm trying to find where the intercept is. Okay? I made the guess. I found the derivative of that function. Now I substitute my guess into the function, divided by the derivative of the function, do that minus that, just use the formula. And now I can use again my calculator. So how am I going to do that? I'm going to start with and it's important, very important, I didn't tell you here, you have to work with radian. Okay, I tried it at home, and I just didn't get an answer right. How do you know if you're not getting the right answer? Every time you press equal, what will happen? It's going to start going all over the place. It's not going to convert. Okay, so you got to work with radian. Okay, so
For all of it.
for this, if you start with quarter pi, if I wanted to work with degrees, what should I write instead of half a pi? What did you write? 90, yeah. So if you're working with a degree, you should do the same thing, but just write 90. Okay? But I'm trying to get you to use radian. Okay? So I can't remember what I was going to do now. Yeah, how do we write in the calculator? So we're going to write quarter pi equal, okay? Then what do we have to write? We have to write, what do we have to write? Answer, okay, which is, in this case, is just quarter pi. I'm basically copying this. I'm copying this
But just for that.
minus, sine answer minus 1 over answer, or you can write answer power minus 1. Okay, I'm going to just stop this one. Divided by cos answer plus 1 over answer squared. Okay, so that is what I'm going to put in my calculator and eventually write 0. And let's try and do it together. So tell me what's the first equal you get. 1, 0, 8.
0, 2, 8, 5.
Hang on. 0, 2, 0, 2, 8, 5. Let me just see that we're on the right track instead of... Yeah, I think we're not too far. A little bit farther. Hopefully we'll get there. And then press equal again.
1, 1, 0,
Yes.
7, 7.
Yeah, much better. 1, 1, 0, 7, 7. Again equal.
1, 1, 1, 4, 1.
1, 1,
4, 1.
4, 1. So every time, just I'm going to push that in. Every time we write equal, they'll take the 1, 1, 1, 4, 1, put it in here, put it in here, put it in here, put it in here, put everything here. We're iterating, we're repeating the process. Every time we're getting something which is a bit closer. If you remember in the language of what I did in the first time, we start from here, then they gave us this, and we get this, and this, we get this, and this kind of process, we're zoning in on it. What's the next one?
So now we're going into possible decimal places. So 1, 1, 1, 4, 1, 5.
Okay, and then?
It's like always 1, 1, 1, 4, 1.
Fantastic.
5, 7.
1, 1, 4, 1, 5.
7.
So what they answered, they gave us in 4 decimal places, which works out 1, 1, 1, 4, 2.
Yeah.
Okay? All right. So if I hope you understand now, if it converges, if you get closer and closer, closer, you're on the right track. If it's starting to go all over the place, then we made the wrong guess. Okay? I'll just stop here and see if I need to do any more.